Starting recording. Oh, okay, cool. Well, I might be able to record. We'll see. Okay, so I'm gonna start now. Anybody who can't hear me or see the screen or anything, just send my message in chat. I'll glance at it as I go along. So good evening again. I hope you all enjoyed your Easter weekend. A nice 4-day weekend, even though you couldn't really go out. I hope you did at least a little bit of labs or studying or reading textbooks or watching videos. So we are on class number 13 now. Yeah, so 14th April, class number 13, lab number 12. So we finished presentation 6 in the last class, and we'll be starting presentation 7 today. Yeah, recording still going, cool. Yeah, so presentation 7, we'll do the first half today, and we'll do the second half Thursday, and we'll finish up this today. So right now we are at the end of section 2.0. So remember, this is the whole CCNA syllabus here, and the first part is very heavily loaded. So don't worry about, we're not halfway there or anything. If you look at the percentage, you'll see why I'm spending so much more time at the front than at the back here. You'll see 20%, 20%, 25%, and then just 10 and 15 and 10. So I want to make sure I spend more time discussing this stuff at the start. And then you'll see we'll get through the last 3 sections fairly quickly, because the reason it's worth 10% is because Cisco doesn't want you to learn as much. They don't want you to go in depth as much as in the first few sections. So we discussed this stuff in the last class. So comparing Cisco wireless architectures and AP modes and describing physical infrastructure connections of WLAN components. So we'll just do a quick recap of all of these things that we discussed last class, and then we'll go into these 2 new sections today. So describing access points and wireless LAN controller management access connections. So telnet, SSH, HTTP, HTTPS, console, and TACACT and radius. This is basically the ways in which we manage these, the main parts of the wireless network, right? So we know what an AP is, we know what a wireless LAN controller is, and we're going to discuss how we manage them now. So these are all the different ways that we could manage them. I will discuss, why we choose certain ones over other ones. And then we'll go through configuring the components of a wireless LAN access for client connectivity using a GUI. So this is basically what we did in the last lab. Click the WLC, enter your IP range, enter your SSID, set up your range properly, set up your DHCP server, those kind of things in a nice point-and-click menu. That is exactly how Cisco wants you to do it. So using a GUI. So that's the start of it. And you could do it in a CLI as well in a lot of environments, but using a GUI offers you a bunch of advantages. One of which is, of course, that it's super simple to configure. As you saw in the lab, it's nice to see a menu and click and use a drop down and just enter your values in a blank field, as opposed to trying to figure out a command line interface, right? So for the CCNA level, at least, Cisco specifically said they want you to use a GUI, a graphical user interface, to configure it. So I don't have a more modern version of the WLC. Packet Tracer is all we have to work with for now. So you already did it in Packet Tracer, and today I'll show you some screenshots of another wireless LAN controller that Cisco has that will look a bit more modern and a bit more fleshed out than what we had in Packet Tracer. And then once we finish this today, I'll show you a sandbox that they set up for another one of their suits that lets you go in and dig around a bit more. So the reason I didn't use this sandbox in the lab is because it is read-only. So I could just click it here. You see it here. So DevNet sandbox, always on, read-only. So read-only means we can't change any of the things here. Yeah, I don't know if you'll hear this. Yeah, 1 second. So I'm making noise. Right. Yeah, so we can't change any of these settings here. We can't. I can't set up steps for you all to run through your own lab. This is all just there, and you could watch, but you can't change anything. So you won't be able to do actual lab in this. But it's nice to see production, modern, super expensive Meraki wireless LAN controller. So I'll give you the links and login and stuff at the end of this class. So yeah, that's it. Let's start the presentation. Yeah, that's it. Okay, I'm not seeing anybody comment or anything. So assuming you all hear me properly. Right, so you all should be able to see this pointer. Okay, right, so go on there. Alright, finish load. No, not paid full screen. Yes, okay. Right, so yeah, as I mentioned, we're going to do a brief recap of last class in this section first, and then we'll go through the management access for these two very important, well, basically the backbone of the whole Wi-Fi network, and then configuring a WLAN using a GUI, as we did in the lab, but in a bit more fleshed out terms, with a bit more features than the WLC in the lab had. And next class, Thursday, we'll go through, but we'll start with section 3, and we'll discuss the routing table and the default router forwarding and all those nice layer 3 or IP layer concepts. Right, so a brief recap of last class. So starting off with comparing Cisco wireless architectures, we discussed some of the different ways that Cisco WLANs can be implemented. APs can be implemented as autonomous APs. Why am I seeing myself here? Okay. Oh, okay, now somebody dropped. Okay, cool. That's good. Okay. So autonomous APs, where each AP basically manages its own configurations. Page went back. Nice. Okay, yeah, should be back there. APs can also be changed to operate in lightweight mode, where they are controlled or managed by a central controller, or WLC. So that's what the wireless LAN controller part is. So we said in autonomous AP mode or FAT mode or standalone mode, people call them by different names. But basically the AP is a device and all of the functionality is used on the device. So the device is managed by itself. You log into either the GUI or SSH session, and you manage everything that you configured in the last lab. The DHCP scope, the gateway, the subnet, the whole IP range, everything else, the DNS servers, everything. Everything is managed in each AP. And that is the advantage that has is that we don't need any extra equipment. So it is a lot cheaper. We just buy the AP and we get everything in the AP. But the problem with that is that we can't scale as easily, because if we set up 2 APs, we need to duplicate the settings there. 3 APs, we need to duplicate the settings twice. And you'll see human error coming into play. You'll make a mistake, you'll mistype an SSID, you'll type all lots of things wrong. Your IP addresses or your subnet mask might be off. And even if you get the first one perfect, the second one might be wrong, or the third one might be wrong. And that's the problem with having a set of autonomous APs in a large campus or in a large business. So what we prefer in larger networks is that they can also be changed to operate in lightweight mode or thin mode, where they are controlled or managed by a central controller. So the WLC provides that functionality. It is the central controller to manage a bunch of different APs in our network. Lightweight APs can be controlled by either an on-prem wireless LAN controller or a wireless LAN controller co-located on another piece of infrastructure. Or the APs can simply be pointed at wireless LAN controller software in the cloud. So we went through the diagrams to show these things. And each architecture has its own set of advantages or disadvantages. So of course, cost is one of the biggest factors in a lot of these infrastructure or architectural decisions. If we only have the money to buy the AP, then we need to run with an autonomous AP, right? If we literally can't afford a wireless LAN controller, then we have no choice. We need to go with the autonomous AP. If we have a bit more money, then we could spend and we could get the benefits of the wireless LAN controller, which will give us a lot less work to maintain the whole network. It'll be much simpler to change, a simple password or a simple SSID using the wireless LAN controller. OPEX versus CAPEX. So this is operational expenditure versus capital expenditure. A lot of businesses like OPEX. If you tell them, you have to pay $100 every month, and you get your Wi-Fi network running, and you get it, it keeps running just by paying $100 a month. Um, a lot of commercial people would prefer that over, you have to convince them to spend $60,000 this month to buy an autonomous AP and two wireless LAN controllers, and a switch and a router and all of those things, just an upfront cost. Usually they prefer the OPEX, and that's one of the big advantages of the whole cloud. A big selling point of the cloud is that all of your costs are OPEX costs. So you pay, however much a month, and you get all of your infrastructure. You don't need to pay a big upfront costs. Right. So this was the first architecture that we studied. So we had the core layer, the distribution layer, and the access layer. As we knew before, this is the typical 3-layer model, but we added in the wireless part of this, right? So all of this is wired, and the autonomous APs were the simplest way to break out the network into the wireless space. So we just run, one cable to the AP, or two cables if we don't have PoE, and then the AP will put this wired network onto the air using different SSIDs. And of course, because these are autonomous APs, we need to literally log into each one and duplicate these settings on every single AP that we set up. We need to set up management, we need to set up this trunk link, we need to set up these SSIDs, and all the passwords and everything else that is associated with it. So it's easiest way to set up a wireless network, but it is the least efficient and the most difficult to maintain and scale. Then we went to this way, where we said, okay, we have enough money now, we have grown enough, and we demanded a wireless LAN controller. So we have this WLC here, and we have the lightweight APs now. So rather than autonomous APs, we have lightweight APs. So they do the same function, they just operate in a different mode. And what the lightweight APs do is they use a regular access connection, so a regular access VLAN here, and they reach their wireless LAN controller, and then they set up a CAPWAP tunnel. So using these tunnels now, they could talk to their wireless LAN controller very easily, and they don't have to care about the underlying infrastructure that much. In this case, we need to make sure that all of these things, so that's why all of these things highlighted in this kind of thick blue color. We need to care about all of this part of the network here, because this entire network is shared between all of these APs. So we need to bridge VLANs through this whole thing, which brings a lot of problems with it, with broadcast storms and everything. In this way, you see no thick blue here. The access network is very simple, and we just need one VLAN. We just need to get some way to get back to the wireless LAN controller, and all of the more complex stuff like the VLAN bridging and everything, it just happens across this tunnel. So that will be kind of auto-negotiated, and all we need to do is maintain this physical connection here. We don't need to set up trunk links or any of those complicated VLAN stuff. This CAPWAP tunnel will handle all of that. Then we talked about the cloud wireless LAN controller. So rather than having the WLC physically in the network somewhere, all we do is point the APs at this cloud controller, which is not a physical device. It is just some software hosted on a server in the cloud. So it'll just be like a public IP or a host name, and we point our APs towards it, and it will set up a logical tunnel through the physical infrastructure again, but going all the way out now. So all the way out to the internet, and hosted in AWS or GCP or a Cisco cloud maybe, somewhere. And the APs will just talk to that cloud and manage themselves. And you'll just point the browser to this Meraki cloud instance, and you'll configure APs through there without having to buy any physical equipment at all. And this is exactly the type of sandbox that I found. So you'll get to play with this a little bit at the end of the lab, well, at the end of today. So lastly, we discussed some more special modes that we can configure APs in, such as local mode. So this is the default mode. We offer a few SSIDs, and then when the APs are idle, they listen for interference and noise, they discover rogue devices, so they do other functions. But if they're busy, they're going to be offering those SSIDs and serving wireless clients, because that is their main job. Now, if we want to force APs to do the other jobs that we want, so the other added functions or benefits that we want on the network, we could force them into these other modes, like monitor mode, where the AP doesn't transmit at all. It only listens to detect rogue APs or IDS events or clients. Flex Connect, so it acts as a backup to the car tunnels by moving traffic between a VLAN and an SSID. So we know how important the car tunnels are for lightweight APs. So if you want to make sure those car tunnels stay up, no matter if the AP goes down or if some other network problem happens, we could use this Flex Connect method to make sure those car tunnels stay up. Then in the sniffer mode, the AP listens for 802.11 frames in the air and forwards them to a packet analyzer like Wireshark. So if we think there's some rogue device, so some malware infected PC somewhere in the air, and we want to get packets from that PC, and we want to sniff out those packets, we could set up a sniffer AP just to capture those packets alone. And we had a few more in a second page there. Now, to end the discussion, we explored some of the physical connections required to set up these WLANs using APs, switches, and wireless LAN controllers. We showed how certain APs would require only a single VLAN and could thus use access ports to a switch, while some would require multiple VLANs for multiple SSIDs and management, and would require trunk ports to their switch. So the lightweight AP requires a single VLAN and just uses an access port, whereas the autonomous APs require multiple VLANs for multiple SSIDs and for a management VLAN. So they require trunk ports to their switch. And usually we prefer the access ports. So in a general, as a sweeping statement, you can say access ports are safer than trunk ports. And you can see why. Access ports mean you're restricted to one VLAN. No matter what, you can't get out of that VLAN. If you're causing havoc, you're going to cause havoc in one network. You're not going to bring down the entire network. With a trunk port, you could possibly bring down all of the VLANs across the network. So we usually very careful about where we configure in trunk ports on a switch. Whereas access ports, it is dangerous, but not as dangerous as trunk ports. We also showed how some APs could use lags to their switches for increased capacity and resilience. So link aggregation groups or bonds, we like for aggregation. So if you have one gig link to an AP, you have maximum 1 gigabit per second to that AP. If you have two by 1 gigs, you could bond them together and get 2 gigs. So you have more capacity, but you also have more resilience. So if you have an AP outside somewhere and you have a cable being run through a heavy duty construction area where equipment passes a lot, there's a good chance that the cable could be struck by a forklift or something else, and then the entire wireless network goes down. If instead you run cables from the AP out to both sides, and then run it back to your switch, then you get some sort of resilience, right? You set up the bond, and the two cables run in 2 different directions. So even if one side of a building goes down, or if something hits one side of a building and the cable goes out there, the other cable will still be up, and it will still be transmitting data. So your whole network won't go down. And that's, of course, the whole point of resilience. Similarly, the wireless LAN controllers could utilize trunks and link aggregation groups to connect multiple VLANs. So just like the APs could do bonds, the wireless LAN controllers could do bonds for the same points of better capacity and better resilience. Right. So yeah, this is the whole point of trunk links versus access links. So we usually prefer these access links because of better security. And then, of course, the AP still wants access to multiple VLANs for management and because each SSID is associated with a particular VLAN, but all of those trunking things happen across the car park tunnel. So we have one VLAN allowed across the physical infrastructure, but across this logical tunnel, we can do multiple VLANs and everything else. Whereas with the autonomous AP, we just need to do a trunk across the physical link. So we have that security vulnerability there. And the same thing in the wireless LAN controller. We have the AP connected here, and as I said, each SSID is associated with a particular WLAN or Wi-Fi network, basically. And each of them is associated with a VLAN. So we have different VLANs for each SSID or each Wi-Fi network. And then on the wireless LAN controller, we have a dynamic interface associated with each VLAN. So each new SSID requires its own VLAN and its own dynamic interface on the wireless LAN controller. Yeah. Now let's continue this discussion of WLANs to expand on the management aspect of these components. So we talked about the data aspect a lot, and how we get data to the APs through those tunnels and everything. And now we're going to discuss the management aspect of it more. So how do we manage these devices? We already mentioned that most Cisco APs have a console port that you can connect to using a serial cable. And the USB to serial adapter, well, I showed you that in class. So that's a little part that you plug into the USB port, and then you get a big connector to plug in the blue console cable to. And in mine, I didn't have this. I just had a direct USB to serial port. But some of them still have this thing. So we could use this console port and this serial cable for initial management. However, you likely don't want to be walking around plugging in a console to all of these APs for later management tasks. In fact, the APs may likely be stuck in high ceilings after the initial setup and will so be inaccessible to you. So, as I said, in most businesses, they don't want to see an AP, right? Most of these devices, if you look at them, they painted white and they made to be hidden in a white ceiling. Not really in the ceiling because you'll block a lot of the signals by putting it in the ceiling, but it's usually like right up against the white ceiling on top, or gypsum ceiling or whatever it is. And it's in a very high place in a lot of places, so that the signals could spread and you don't need to worry about people walking in front of it and putting a lot of electromagnetic noise around the AP because it's so high up and protected in the ceiling. But that also means that we can't manage them, right? If anything goes wrong with that AP, we might just lose it for a few days or a few weeks until somebody could get a ladder or a piece of scaffolding to get up there. So we won't be able to access those APs. So rather, we want to set up some other means of remote management to these APs. So several remote management options exist. So Telnet, SSH, HTTP, and HTTPS. These are all ways that we can remotely reach that AP in that high ceiling, rather than this console port that we'll use only for the initial management. So we will discuss security more in the next section. It is one of those big sections here. But basically, Telnet has been largely pushed aside because of its security weaknesses. So in a nutshell, if you Telnet across the device and you put in your username and password, anybody in that range of the Telnet session could read that password. Just straight off the line, they could read in Wireshark, this password was Cisco 123, which is obviously a huge security weakness, right? So most CLI-based sessions now therefore now take place using a secure shell or SSH, or they should in theory. So in actuality, you'll see a lot of old businesses, a lot of current businesses, I should say, they still use devices that only support Telnet. So there was actually an SSH version 1, and a lot of these older devices, especially the older Cisco devices, they mainly built to use Telnet. They have kind of partial support for SSH v1, but a lot of our laptops just don't support SSH v1. So that's why you'll see a lot of engineers just default and accept that they have to use Telnet sometimes. But really, we should be pushing for SSH v2, which is the modern encrypted safe version. However, rather than using a CLI, most wireless engineers prefer to manage their APs through a web GUI, using either HTTP or HTTPS connections. Of course, HTTPS is preferred because of its stronger security. So that's what the S there is for, right? And that's why you have the green lock in the HTTPS websites, like google.com. You'll see a nice green lock there, which means that your encryption to the server is encrypted. Your connection to the server is encrypted. So just like before, if anybody tries to pull that packet as you are talking to the server, they'll just see gibberish on the screen. They won't be able to see, whatever it is you're Googling or searching for. That HTTPS connection means that you have end-to-end encryption to that server. And in the same way, when we manage our APs, we want HTTPS because somewhere along the way, we need to authenticate and we need to put in a password or a token of some kind. And we don't want people seeing these bits of information that we send into this wireless LAN controller. So we prefer HTTPS. Besides being easier to navigate and view graphs and charts in, web GUIs are also used extensively in lightweight APs and wireless LAN controllers. So, as opposed to routers and switches, where we mostly manage them using command line interfaces, in the wireless networking world, you'll realize a lot of the management is done in web GUIs. Because they are easy to navigate, they're easy to view graphs, they're easy to view charts, and you'll see from the sandbox that these things can be very useful for wireless networking. So therefore, you'll likely use a console cable just to set an IP address on an AP, and then you'll use your browser to manage it thereafter. So I have set up a few wireless networks like this. You pull the AP out of the box, you use your console cable or a short Ethernet patch cable just to SSH into it for the first time, and just to set an IP on it and point it to the wireless LAN controller. And then after that, you screw it up on the ceiling and you run the cables and everything. And then the AP will auto connect to the wireless LAN controller using the settings that you put in. And then after that, you just log into the wireless LAN controller through a nice pretty dashboard, and you click away. That's it. You don't need to worry about the CLI after that. So similarly, you'll use your browser to log into any wireless LAN controllers that you purchase for your network. Many wireless LAN controllers also support SSH for CLI access. So usually this is a in case of emergency kind of thing. If you can't access the browser dashboard for any reason, you could SSH into your wireless LAN controller. But usually because of the graphs and everything, you'll want to use your browser. So you can use either of these ways to perform your initial configuration on the wireless LAN controller. So just like the initial configuration on the AP, you go in and you change your IP addresses, your domain name, everything else you want to configure on your wireless LAN controller. And from the lab that you did, you now know some of the things that we want to configure on this WLC, right? The DHCP scope, the DNS servers, the gateway out to the network for different networks, all of those things. So we want to configure those things before we point the APs to it. So most likely you'll be managing your wireless LAN controllers and their attached APs using web GUIs, not really command line so much. As with the APs, these web GUIs allow for simpler management and navigation of the wireless LAN controller functions, and allows for easier display of statistics on your WLAN. So connected clients, current throughput, dropped frames, wireless maps, etc. All of these things are much easier displayed on a web GUI as opposed to trying to do it in text. And this is why a lot of the wireless LAN controllers and APs, well, they have their browser or their web GUI much more developed than their command line, as opposed to routers and switches where it's the other way around in most cases. Now, of course, to improve accounting on your APs and wireless LAN controllers, so accounting just means knowing who changed what on your infrastructure, you'll likely want to implement multiple user accounts on all of your infrastructure. So this is not specific to wireless networking, only. You want to do this across the entire network. If somebody logs in and changes, IP address or some kind of pairing on a router or sets up some new VLAN on a switch, you want to know who made that change. Because if it kills the network, if it destroys something 12 o'clock in the night, you want to go back through your logs and you want to see who made that change and why they made that change. So rather than creating these multiple accounts in different places, which is error prone and time consuming, just like with the APs, you can implement a TACAX or radius server to manage all of your user accounts centrally. So it's two things we focus on here, right? One is that you don't want a shared account. So if the default login on a Cisco AP, just as an example, is Cisco, you don't want everybody just sharing that Cisco account. Because then if somebody makes a change, 12 o'clock in the night, and the next morning, you don't know who made that change. Because they just logged in with Cisco. If they logged in with, John.do, then you know it's them. You could see it in the logs. You'll see, John logged in at 12. He created this new VLAN. The network broke at 12:30, but John logged out after that and he went to sleep. That was it. But at least you have a name there, so you have somebody to call. Rather than if Cisco logged in, you don't know who logged in. So we could either create John's account in every single device across our network, which is error prone and time consuming, or we could implement this TACAX Plus or radius server, which helps us manage all of our user accounts centrally. So these two names is basically just two databases. So it's a central place. We log into the server, we create a username, we create a password, and we could create a bunch of other things, but mainly the username and password. And then we could point other devices to that. So we'll have a diagram in the next slide, but that's the concept of it. So rather than creating the account in every single router and every single AP and every single wireless LAN controller across the network. All we do is we point all of these devices to one database, and we tell it, look, if somebody's logging in, check this database, and their username should be here. And the big advantage with this is, besides removing the error proneness and the time consumingness, if somebody leaves the company, we don't need to log into every single router and every single switch and delete their account from every single device. Or if somebody joins the company, we don't need to log into everything and create a user account and everything. We have one database where we delete one row or add one row, and they can access everything on the network. And that's the big advantage of these servers. Well, the second big advantage. So you should always try to implement these AAA servers. So that's a global name for these things. AAA servers are usually either TACAX Plus or Radius servers. So the group of them is called AAA. Authentication, authorization, and accounting. Yeah. Rather than shared accounts relying on local authentication databases. You can also extend these AAA services to authenticate clients connecting to the wireless local area network. So in the same way that we use these databases for management connections, so making sure you have an account before you log into this router, you could use that to authenticate people connecting to your wireless network. So you could say, okay, John needs access to the Wi-Fi network, and he also needs access to manage your router. So we could create, we could use the same database and create info for John, and let the APs and the wireless LAN controller check this database for John's account. So this is what it looks like, right? We have a switch and we have a router here, and both of them are Radius clients. So the clients are the things that could query the database. So these things, if somebody plugs in a PC in here, so let me say John has his terminal here, and he wants to SSH into this switch, or he wants to SSH into this router, he will use PuTTY, and he will point it to the IP of either of these devices, and he will tell them, look, I want to log into you. So as you know, the first thing that these devices are going to ask him is, what is your username? So he will tell them, okay, my username is John, or John.do, or something like that. Then these devices will put a query against this database. So query credentials against, well, the Active Directory database or the Radius database or whatever it is. Some AAA server. They will query the credentials against. They will say, hey, this guy want to connect to me. He just submitted these credentials. Just check that there. And then the Radius server will check it and say, hey, I seen a John.do here. No problem. Okay, send back a message saying I seen him. So you see the credentials accepted, or the credentials could be not accepted. And this process could be repeated. So he could ask, they could check the username, go there, check the username, come back. But they could also add, hey, this username have a password. So check him for that password. Come back here, you see a prompt come up saying password. Then John enters his password. He says, hey, this is the next bit of information he sends. So send it again, and then the Radius server will say, okay, username, this is the password next to it. Check that password. Then send back, access granted or access denied, and then send that down. You see the kind of flow of information there. And it's the exact same thing with the router here. So go up, check username, it comes here, go back, check password, and go back. And of course, the big advantage there is this guy holds the information for everybody. So it's just one place to manage all our user accounts. So now let's walk through some of the configuration of wireless local area networks using a Cisco wireless LAN controller. As we discussed before, most engineers configure these types of networks using web GUIs, so we will be doing the same. To begin, we are going to let our WLAN authenticate potential clients using a Radius server. Basically, every time someone tries to connect to our WLAN, our wireless LAN controller will relay the entered credentials or username and password to the Radius server, which will validate those credentials. So just like we did for management here, every time somebody tries to access our Wi-Fi network, we're going to prompt them for a username and password, and we're going to have this Radius server check for that username and password. If it's correct, give them access to the wireless network. If it's not, deny them access. And this is an alternative to the common PSK or pre-shared key that we usually have in Wi-Fi networks, where we just have a standard password and everybody just has to enter that same password for the network. And the But the difference is that we have some accounting here, right? So if somebody connects to the network with a particular username and password, we know who connected to the network, as opposed to if anybody entered the password, we don't know who entered that password. We just know they were granted access. So for instance, if John came into the company or came into the compound, and we saw on the WLC that his credentials were entered at 12 o'clock in the night, and nobody expected John to be on the compound connecting to the wireless network at 12 o'clock in the night, then we know something is up there, right? If he had just entered a password, we wouldn't have known it was him. It could have been a security guard around the compound. It could have been a tier 1 or a NOC engineer somewhere. It could have been anybody else, anybody who has that password. So using this username / password combination really gives us a lot of those accounting features. So in our left navigation menu, we select radius and authentication, and then click the new button in the top right hand corner. So I'll show you screenshots as we go along. As I said, we don't have access to a real life WLC anywhere. So we just have to go with screenshots from Cisco for now. So you see radius authentication. So you see this looks a lot more fleshed out than what we have in Packet Tracer, right? But we have to go along with these screenshots for now. So you see AAA, radius, authentication, and then click new. So left navigation, radius, authentication, and then click new in the top right hand corner. New. We assume that our radius server has already been configured. If you want to set up a radius server by yourself, look for servers such as a free radius server. So this is an actual package that you could install. So you could set up a Linux machine and set up free radius on it. Just Google free radius server setup, and it'll walk you through a big long guide for it. In this example, we're not going to focus on that because that isn't in the CCNA syllabus. So we're just going to assume that some sysadmin somewhere set that up for us, and we have it already set up. So all we do is we enter the correct settings for the radius server and we click apply. So this is what a normal radius server looks like, right? So we have priority, IP address, then a shared secret, which is kind of like a password, a port number on the server, and then different things, timeouts and all these things. So basically, if we assume a sysadmin sets up this radius server for us, they will give us all of this information. They will tell us, look, we have a radius server, the IP address is this, the shared secret is this, give me the IP of this wireless LAN controller, and I will set it up on my radius side, and you use all of this information, the IP address and the secrets and the port number and everything. You set this up, and they will give us that. So all we do is, when we go into this menu, this radius and authentication menu, and we clicked new here before, we just enter that information that they gave us, and then we click apply here. Next, we will configure our dynamic interface on the WLC. You may recall that we mentioned that every VLAN on the WLC can be associated with a dynamic interface. So these are the dynamic interfaces now. We now navigate to controller and interfaces. You see controller on top there, and then interfaces, and then click the new button on the top right hand corner. We will then be prompted for some more advanced information related to the dynamic interface or VLAN. Remember that this information will dictate the address scheme of the VLAN or SSID on the WLC. So you must enter this correctly to ensure that the APs are provisioned correctly from this WLC. So see there, controller, we went. So when controller interfaces, and we click new there. After we click new, we get this page. So controller interfaces, you see interfaces still light blue there, so it's still selected. And then we have all of these things set up. So we have a VLAN identifier, we have IP addresses, netmask, gateway, prefix length for IPv6, primary DHCP server. So in your WLC lab, you had set up a lot of similar information. It's just that the interface looked different. So as with everything, focus on the concept, and you could apply it in every interface that you see. When I give you the sandbox lab in a little bit, you'll see that it doesn't look anything like this either. So this was just some random Cisco WLC that they use to showcase this stuff, but every WLC that you come across will be set up slightly differently. So the idea is just to understand the concepts. So you know what a VLAN is, you know what this VLAN identifier needs to be, you know what the IP address is, you know what a net mask is or subnet mask, you know what a gateway is. I don't think we covered gateways too much yet. You'll see it in the next section. But once you understand all the concepts, you could apply it in any WLC. Yeah. So you enter information and you click apply. Now we move on to actually creating our WLAN on the WLC. Once you create this WLAN, this information can be propagated easily to all of our APs to create extended Wi-Fi networks. So that's what we want, right? We want this WLC to push out all of this information that we configure in this central node and have it automatically duplicate the information across all the APs. So we navigate to WLANs and then create new. Create new and click go. So you see WLANs, create new, click go. That's what we do. Then all we do here is set up a profile name and an SSID. So this is the actual name that we'll see in our PC or our phone. So you know, we could put engineering, guest, CEO, knock, whatever it is. We just name it appropriately and give it an ID. And then yeah, so that's what we see here. Once we click the apply button in the top right, so I kind of cut off the apply button here, sorry. But you just fill in this information there and you put the apply button in the top right here and you create it. And then it will carry you to another page here. So we are then taken to another page where we can edit general settings, security settings, quality of service profiles, and more advanced WLAN settings. So Cisco doesn't want you to know all of these things, right? You'll notice that I kind of glossing over a lot of these settings in this page. They specifically didn't ask for you to understand everything here. So for example, radio policy. Okay, maybe radio policy is a bad one. Multicast VLAN feature, they didn't ask about that. So I focused on, let me see if I can find it here. No, go back. How did I get out? Right. The ones I focused on here are the ones that they specifically called out here. So WLAN creation, security settings, quality service profiles, and some of the advanced settings. But they don't want you to understand every single thing. Else, you know, your head will explode. So don't feel like you need to memorize and understand every single piece of advanced configuration in this WLAN setup. So you see the same names that we had there, same names. You know what status and enable is. So you can imagine what enable is there. So status controls whether the WLAN is on or off. So if you want to disable it for any reason, you just come here and uncheck this and click apply. Radio policy lets you switch between the different generations of Wi-Fi. So if you want to only support 802.11a devices, you could click this drop down here and select 802.11a, just as an example. The interface drop down controls the dynamic interface on the WLC that is bound to this WLAN. So interface or interface groups. So we had created an interface called engineering before. We just drop down and click engineering here. So this is how we bind our WLAN to this dynamic interface. The next two options allow you to enable or filter multicast on the WLAN and to control whether the SSID is broadcasted or not. So we'll go back here, multicast VLAN feature. I've never seen this really used in networks. I guess if you use multicast in a network, you could play around with it and see if it really makes a difference. I remember I had tried it out in my networks and it didn't really make any sort of difference. But the broadcast SSID feature, basically, if you pull up your Wi-Fi card or your NIC on your laptop, you see the names of different Wi-Fi networks there. You could theoretically be sitting next to an AP, and that AP could be functioning perfectly, and you will never see a network show up there. And that is what this broadcast SSID feature is. It is kind of used as a security feature, a little bit. If you want to hide a network for some reason and make sure people know the name of the network that they want to connect to, they will need to specifically go into their phones and enter a manual name and then a password or their credentials. So it's kind of like an extra layer of security, but most of the time it's just inconvenience. So most wireless engineers that I've talked to usually just leave it on because you have your password or your username and password to protect your network anyway. And most of your users non-technical, So they don't want to go in and set up a manual Wi-Fi network for any reason. They want to see the network show up, they want to click on it and click connect, and that's it. The password is already kind of a hassle for them. So you always have to balance usability with security. So we then move on to the security tab on the WLAN. So you see security here, so we were just a general, right? So we move on to security now, and we have all of these options here. So it's kind of blurry, but hopefully you can see it a little bit there. And all of these screenshots in the textbook as well, by the way. So if you want to see them, this one blurry because it was very small in the textbook. But you'll see a lot of advanced settings here. We'll talk about the important ones. So this page provides a ton of controls for very granular security settings, but we will be focusing only on the main ones. The following table shows the layer 2 security options. So of course, when we talk about security, we have none, right? No security. You could put your Wi-Fi network as open. So some people put their guest networks as open. Some of them might put a basic password on it. Some of them just leave it as open, depending on your customers and depending on who you're going to serve with your guest network. Then we have WPA and WPA2, which is Wi-Fi protected access or Wi-Fi protected access 2. And we discussed that already, I think. Yeah, we went through the security there. And the key strengths and the weaknesses in the IV or the initialization vector and all of those things. And the big summary was WPA2 is much more secure than WPA1. And then we had 802.1x, which is EAP or Extensible Authentication Protocol, authentication with dynamic web. So this is what they use usually if you want to prompt somebody for a password, a username and a password. We went through web, static web or web, and we said it was completely broken. Don't use web ever. And then you have CKIP or Cisco Key Integrity Protocol, which is not very open. And then you have different combinations. So you have none and EAP pass-through, which is some kind of complex open authentication with remote EAP authentication, which is kind of a complicated version of this. So it'll be open, but it'll prompt you for username and password either way. So we could configure all kind of complex stuff here. I'm only going to discuss the ones that Cisco themselves highlighted, which is the common ones that you'll see on most wireless networks. So we can then configure whether we want to enable WPA for backwards compatibility or only enable WPA2 for better security. In this case, we have chosen WPA2 plus AES with a PSK or a password. This is very common. Well, this is a very common choice in home Wi-Fi networks. We could also utilize 802.1x to utilize our radio server that we configured before. Next, we move on to the quality of service profiles, so QoS. By default, all frames from all VLANs or WLANs are classified as silver or best effort and are thus treated equally. We can use quality of service to prioritize certain frames from certain WLANs over others. So this one is very blurry, but you can see there it's selected as silver by default. So just Cisco doesn't want you to lose QoS at all, right? It's a huge topic. But just as a quick run through, QoS is basically taking one section of a network and saying you want certain customers to have a higher priority or a higher preference in a network. So if you have some corporate customers that are paying a lot more than some residential customers, you could say, okay, I'm going to create a QoS group called Gold, and customers in this Gold group will always have their packets prioritized in every single router that they pass through. So if there's a backlog, if a link is being maxed anywhere and there is a queue or a buffer in any router, these packets from these Gold customers will always be pushed to the front or will always be least likely to be discarded if anything is being flatlined or any link is being maxed out. So by default, everything is silver or best effort. So we don't want to prioritize anybody as first come first go, basically first in first out, which is FIFO. So it says it there, silver or best effort. But in more advanced networks and in certain cases where you have a lot of links being maxed, you want to set up these different classes for different quality across the network. So finally, we can use the Advanced tab to configure certain specialized settings for WLAN. For example, we can adjust the default session timeout, block P2P or peer-to-peer on the network, or set a maximum number of allowed clients on the WLAN. Once we are happy with our WLAN settings, we click the apply button in the top right corner. So these are the more advanced stuff here. Again, it's a lot of crazy advanced stuff that you don't want to mess with in most cases. But some of them decently easy to understand. So like maximum allowed clients per AP radio is just the maximum number of things that could connect to AP. If you connect too many wireless clients to a single AP, you'll start to realize that a lot of packets being dropped, a lot of frames being dropped by the AP, and everybody just has a slow connection. So you might want to limit this to 50 or 100 or something. But you could play with this in an AP. If you have a safe WLC or a safe AP, you can play with some of these settings and read up on them. For the CCNA level, Cisco they don't mention these things at all. So the basic stuff, and then you click apply. So if you are really interested in wireless networking, check out this Cisco Meraki sandbox. So I'll go into it a little bit and show you some of what you can do at this link. And this is what it looks like, right? So you'll notice it looks a lot sharper and a lot more modern. But again, the settings are very similar. So showing 4 or 15 SSIDs, you know what the SSID is. Enabled, you know what the enable and disable toggle does now. You know why we need to name our networks. You know what the encryption is, bandwidth limit. So you know what, we kind of have an idea what bandwidth is. So that's just the speed across the network. Client IP assignment. So you know what a DHCP server is, and you know that we need to set it up on a WLC. VLAN tag. So you know why we need to set a VLAN tag on a lot of these things. We didn't cover splash pages and these more advanced things yet. But again, you know the basic stuff here. And that's it. So that's it for today. Right. So we covered the API and